All right. All right. Hello, everyone. My name is Philip.
I'm Edward.
Nick.
Oh, I'm Nick. I had said it
And
at the same time.
our project will be today about water supply and climate change. And this is the table of contents and introduction. Water is our planet's most essential resource, as we know, and the demand on water is increasing due to many factors like population growth, climate change, and agriculture growing and expanding. And rising the global temperatures are disturbing the rainfall patterns, reducing the snowpack, and increasing droughts and floods, which is also affecting the availability and quality of water. Moreover, agriculture is one of the biggest sectors that is affected by climate change and water supplies because water is very important and agriculture heavily depends on water. Without water, we don't have any agriculture. Also, we will explore the impact of climate change on water supply and agriculture and dive a little deeper into details like reduced snowpack, early snowmelt, groundwater depletion, and we will go over solutions and strategies that can help our communities and also farmers to manage water more in a more sustainable way. And first, impact of climate change on water supply. So climate change affect where, when, and how much water is available. Climate change is affecting the whole world, especially the southwest and the northeast. According to the Environmental Protection Agency, or also known as the EPA, the top three climate impacts on freshwater resources are reduced water supplies, impaired water quality, and stress on water infrastructure. In other words, climate change is reducing snowpack and groundwater supplies while increasing the water demand, leading to diminished and less reliable water resources, especially in the west of the United States. Also, climate change is expected to worsen water quality by increasing population runoff and pollution runoff and harmful algal blooms, also salt water intrusion, which together and all these threaten freshwater supplies, aquatic life, and human health. Also, aging US water infrastructure faces increasing strain from climate change, as extreme weather and related impacts can damage systems, causing failures in creating competition for limited water and energy resources. And the impact of climate change on agriculture. Agriculture depends heavily on water and on the weather. Climate change will make agriculture even more difficult. And some of those impacts are many, and they include altered precipitation patterns, temperature increase, pest and disease, reduced productivity and yield loss, rising sea levels, and the increase of the frequency of extreme weather events.
All right, so furthering on Philip's points, we're gonna dive into snowpack specifically. So in regard to reduced snowpack over time and early snowmelt, which can affect water availability. So a quick fact is from 1955 to 2023, April snowpack declined 18%. And that's significant because that's close to a quarter of the available water that we'd be gaining from snowpack to use in agriculture, drinking water, or other necessities. And this largest decline was noticed amongst the Western United States, so California, Washington, Oregon. And that's also pretty significant because California is known to be a drought tolerant state. So we can't really afford to be losing one of the largest sources of water, which is snowpack. And peak snowpack, which is when snowpack reaches max depth and water content. So basically, the mountains are kind of full of snow. You know, they have their most water content has the most potential to melt and come down for our use. That decreased an average of, I'm sorry, is trending earlier across all states. So basically, the snowpack builds up sooner in the year and melts sooner. So which kind of messes with the water availability. So it might be available when we don't really need it, but when we more so need it, we might not have access to it. And that's where we get into from 1982 to 2023, snowpack season decreased on an average from 15 days out of the entire season. So essentially, we're losing out on 15 days of water storage, which equates to millions and millions of gallons. And the largest effect expected out of snowpack, reduced snowpack, was the timing of water availability, which I had mentioned previously. So essentially, it becomes less available during the end of summer months when we need it more. Now, groundwater overuse and depletion kind of goes hand in hand from snowpack because the snowpack will kind of melt, come down, and become groundwater or flow into streams and other sources of water. Um, so groundwater is the largest usable fresh source of water, and it comprises 50% of the drinking water in rural areas because usually you can't really get it from like a spring mountaintop or might not have direct access to the snowpack. So that's where groundwater really comes and is really essential. And excessive depletion via pumping, so taking that water out of the ground, lowers water tables, limiting the future accessibility of that water. So you're gonna have to drill down deeper and pump harder, which is gonna use more energy and in turn cost more money. And that's gonna cost the consumer, which is you, you're gonna have to pay a lot more money for that water. And pumping near the coast, another side effect of that is that you're increasing the chance of the salt water contaminating our fresh groundwater. So when you're messing with those underwater water tables, you're essentially disturbing the balance, and you could be kind of mixing the salt water with our fresh water. But that kind of becomes more prominent if you're overusing it. And finally, runoff from fertilizer, waste byproduct, and other erosion complicates the issue by contaminating our fresh groundwater. This is kind of where you also see like when you're irrigating something and you know you have high salts in the water and now you're irrigating your crops with that. This is where that kind of comes into mind.
Some of the groundwater overuse and depletion solutions. A few things that we can do is regulating and limiting pumping. In certain regions, we hope that they regulate strict water laws, acts, policies, and laws that would allow control of the amount of water that can be extracted from qualifiers or aquifers, I mean. Another thing we can do is artificial recharge of aquifers. This technique would allow groundwater recharge to naturally filter water in large areas, such as like farmlands, and would help areas that have been put through continuous use of pesticides and nutrients for large water scale production. Another thing we can do is promoting water conservation in agriculture. This is just a practice that can be taught and also used throughout agriculture, such as drip irrigation, sprinkler systems, drought-resistant crops to reduce water demand in farming. Um, Another thing we need to start implementing is water-saving technologies, water-efficient fixtures, rainwater harvesting, and gray water recycling in residential and commercial settings to reduce groundwater dependency. And then last but not least is raising awareness and education. We need to educate communities and farmers about the importance of sustainable water use and the risk of overextending the use of water consumption. And then we should design sustainable land use and plans that incorporate groundwater recharge zones and limit urban sprawl in areas prone to depletion to preserve aquifer health and monitor data that would allow technologies to track groundwater levels and ensure sustainable extraction rates. And in conclusion, you know, groundwater recharge has the potential to offer long-term benefits for sustainable water management. It presents challenges though, in every area, especially throughout the seasons. And just like Nick and Philip were mentioning about snowpack, how we're starting to lose a lot more water throughout the year. So, we just need to learn to plan to ensure it can be implemented safely and effectively, ultimately helping to mitigate long-term negative impacts. And this is crucial for strong water and supporting populations during shortages. And investing in sustainable practices, enhancing infrastructure, and promoting responsible water use. California is trying right now to mitigate the effects of shrinkage from snowpack and safeguard its water resources for the future. I and my team hope that, water conservation practices can help people to help the ecosystem, and through continued innovation, through community engagement and adaptive management is essential to overcome ongoing climate challenges and ensuring the preservation of water resources for generations to come.
Perfect. And this is our reference page, and thank you for your attention.
Thank you so much.
Thank you.